All right, let's look at our instructions. It says first set each equation equal to 0. Last night on the homework, tell me, did you have to do that or was it already equal to 0? Okay, so if it's not today, you're going to have to move it over. Get it equal to 0. So on that first one, how do I move the 4 over to the left?
Subtract 4.
Subtract 4, okay. Then it says factor each equation. And then a side note, it says remember if there's only 2 terms, look for a GCF first, or look for the difference of 2 squares. We didn't do any of those yesterday. Do you remember what conjugates were? X plus 7, x minus 7. You know, and it's multiply out special. Then set each one equal to 0, solve for each in factor, and then write your answer in brackets, and that's called set notation. Continue to practice using that set notation. So let's just kind of look through these and see if they make sense. I've tried to give different illustrations based on the problem, so let's see if we can go here. Now, you already said we have to set this equal to 0. So that's our first step. Let's subtract 4 from both sides. Be careful when you do this, Noah, that you don't combine the x's and the minus 4. So that's what your second line is going to look like. Just a minus 4 along there. Anybody need a pencil? So now, we have to try to factor this. What multiplies to negative 4 that adds to negative 3? The negative 4 goes there, the negative 3 goes there. What do you think? Raise your hand if you think you can think of that number. What multiplies to negative 4 adds to negative 3? Anyone besides Luke? Zach, give you a try? Negative 4 times 1. Do we agree? So that adds to negative 3. Now, yesterday we didn't review this idea, so I want to review it just so we're comfortable. Reviewing the idea of factoring by grouping. I'm going to put a box around these first 2. What's the GCF of those first 2?
X.
Just an x. So I put an x out front. I have an x minus 4 inside. X minus 4 at the back. And then I got a big box in the middle. What goes in the middle? How much?
1.
Yep. What kind of 1? Plus 1 or minus 1?
Plus.
Okay, so my answer is x plus 1 times x minus 4. Now that's the factoring by grouping. Was there a shortcut we could have used?
Yeah.
Is it just x squared? You bet. So can we use these ideas, x minus 4, x plus 1, from right over here? Yeah. If you don't remember that, you can go through the normal process. All right, so now we're going to set each one of these equal to 0. X plus 1 equals 0. X minus 4 equals 0. Let's solve each one by subtracting 1 and adding 4. So x equals negative 1 or positive 4. I guess I should write this in set notation, like so. Did we talk yesterday about why you don't write it with parentheses? When you have 2 numbers written with a comma in between and parentheses, what am I representing, Brett? A point, yeah. So that's what we use set notation. Guess what this means? Negative 1 and 4. Guess where the parabola crosses the x-axis? At negative 1 and 4. If you drew this parabola, that's where it would cross. And that's the idea. All right, number 2. We got to set it equal to 0. Are you going to move the x squared over? Or are you going to move the 6x over? All right, good idea. Always keep your x squared positive. So plus 6x to both sides. There's only 2 terms, Luke. So when there's only 2 terms, that's kind of, it puts it into a special category. We look for GCFs and we look for difference of 2 squares. Difference of 2 squares is the easy one. Is it a minus? So it's not the difference.
If you get to the difference of 2 squares,
It would be like x squared minus 36, x squared minus 81, x squared minus 100. But it's not that in this case. We may get one like that on the back page. So if it's not a difference of 2 squares, what's in common with the 2 parts?
X.
They both have an x in, so take it out. We're going to the mall. We drag x along. What's left when we take the x out, Brett or Abby? Thank you, sir. How many parts do I have to my answer? 2 parts. The first part is x equals 0. The second part is x plus 6 equals 0. Tara, the x equals 0 comes from the part right in the front. So I subtract 6. I have 2 answers. Which one do I need to write first?
-6.
Okay, just the smaller one, -6. And boom. Okay? So there we go. Good morning. Thank you.
Good morning. You're welcome. Thank you.
All right, flip her over. This is intentionally put on here with a negative 2x squared. It's intentionally there to make it a little bit more challenging and difficult.
You add it to the
I don't like negative x squared. Now everything else, we've moved everything to the x squared. Here we're going to move the x squared, and why? Yeah, we want to make it positive. So add 2x squared to both sides. Plus 2x squared plus 2x squared, draw your line. 0 equals 2x squared plus x minus 15. Now before we go any further, give me some setup information. Are we going to be able to use the shortcut on this?
No.
I'm hearing no. Why Luke?
Because there's a 2.
Okay, there's a 2 in front of that x squared, so you can't use the shortcut. So we're going to have to do factoring by grouping. You know, with the parentheses and the box and the parentheses, which is no big deal. Second small issue. What goes in the factors of circle? Nice, Brett. -30. Tell me why. Yeah, you multiply that 2 times the -15. All right. And what goes in the adds to box? 1. I tried to create this problem with have as many special cases as possible so we cover all the scenarios. All right, so 1 and -30 doesn't work. 2, -15 doesn't work. 3, -10 doesn't work. 4 go in?
Yes.
No.
No. 5?
Yes.
-6. Hey, -1. That's what?
Opposite.
That's really close. So my answer must be -5, +6. Does that ring a bell? Haley, is that familiar? Okay, so let's replace the 1x with -5x and 6x. Notice I still have the 0 equals. Drag down the 0 equals, put a box around my first 2, and do a little examination.
X.
You think x? All right. I take an x out. Noah or Zach, when I take an x out, can you tell me what's left?
2x.
Good. All right. Nice job. Nice big box. Make your box good size because remember in your box, Kyle, you got to put a plus number or a minus number. And then at the back end, we have, again, a 2x minus 5. Now, special scenario here. We don't just drop the 6 down.
No.
We have to think something. Think me through it. Talk me through it. Ryan. I agree. How'd you get it? I like the +3.
+3 times -5 is -15.
Okay. And not only that's true, but what else?
And then 3 plus 9 times 2x is 6x.
Good. So 2 things. So it's a +3. And you have 2 reasons there. 3 times 2x is 6x. And 3 times -5 is -15. Excellent explanation. Well done. All right. So 0 equals 2x minus 5, x plus 3. Is it factored? So that's the hard part. The rest is pretty easy, isn't it? Split it up. 2x minus 5 equals 0, or x plus 3 equals 0. How do I solve the 2x minus 5?
Add 5.
Add 5. Thank you, Jalan. Divide by 2. x equals, do I want to say 5/2 or 2.5?
2.5.
Does it matter? Okay. I'll say 2.5 just because you did. Over here, subtract 3. Put my answer, -3, comma, 2.5. Now let's talk about the problem and kind of review it. First part is setting it up for success, getting it equal to 0 with your x squared positive. Next, realizing you got that -30. Next, the grouping part, getting to the factors, to right here. Then we break it up and solve. John?
I noticed a shortcut.
Is there a shortcut on this one? No.
Yeah. If you take your factors,
Uh-huh.
divided by the first number, your 8 mark, then you get
In this case, it works, but that's not always true.
No, because it's not -2.5. It's the opposite.
Yeah, it's divided by it and it's the opposite of it. So there's a lot of caveats to your special case, so it's probably not a special case. It just happens to work. So, all right, let's look at our last one. Is it equal to 0?
No.
Do you want to move the 9, Abby, or the 16? Your choice. Why? Okay, that's good. We don't want a negative x squared. I like moving the 9. 16x squared minus 9 equals 0. Okay, now I need to come back over to the same place I was before, and I'm going to ask Luke the same question. 2 terms, 2 possible special cases, either a GCF or the difference of 2 squares. Let's start with the easy idea. Is this the difference of 2 squares? Is it a difference?
Yes.
Is that a square, 16? Is the 9 a square? So, is it the difference of 2 squares? All right, I need to remember a simple word. C-O-N-J-U-G-A-T-E-S. Conjugates. So, here we go. Does anyone remember what the conjugates would be? Katie?
Would it be 4x minus 3?
Uh-huh.
4x plus 3?
It would be. Nice job. Conjugates are really marvelous because when you multiply them together, the middle terms drop out. So is this problem actually a pretty easy problem now? Yeah. Let's break it up. 4x minus 3 equals 0, or 4x plus 3 equals 0. Add 3. 4x equals 3. Divide by 4. Do you want to put 3/4 or do you want to put 0.75?
3/4.
3/4. On the other one, subtract 3. Divide by 4. Is it valid to write my answer that way? Is that okay? Plus or minus? It's still in solution set notation, so it's still good there. So flip back to the first page. Let's look at our instructions. Is it important to set it equal to 0?
Yes.
Very much so. What should be a little note here that I want to highlight that Abby talked to us about?
You don't want to change the exponent to...
Okay, so make sure x squared is what?
It's positive.
Is positive. All right. Factor each equation. Remember, there's only 2 terms. Luke, this is what we were talking about, you and I. Look for the GCF first or the difference of 2 squares. Okay? Then, set each factor equal to 0. Solve for each factor. Write your answers in brackets. Now, remember, our answer is really where the parabola crosses the x-axis. That's what we're really finding here. When we say solutions, we're finding where that parabola crosses the x-axis. So in many cases, how many answers are we going to have? 2. On a very rare occasion, You're going to get the same answer twice. In that case, only write it once. If you get x equals 5 and x equals 5, you don't need to say 5, 5. Just write it once. Can you? Jalan. I guess I could Jalan. But you don't need to. If you're going to say it, just say it once and say it strong. Make sense? So really you don't need to.